Hello, I am Josh Mitchell with Middlesex University, and in this video I'm going to be going over the advancements I've made on my submission for PD3442 Mobile Robots and Manipulators for the serial manipulator simulation. I'm going to assume you've watched the previous video, which was sort of a basic submission, and any of the code and stuff that was related to that I'm not going to be going over. So if you haven't watched that, go and watch that now. But assuming you have, you will have already noticed some big changes in my 3D picture to do with my robot arm. So obviously, I now have a much more optimized arm with only a few links. I still have this first twist angle from the bottom going up through my turtle bot, which allows me to just still rotate the floor. The reason for that one is because without that first twist angle, all of these joints would be swinging, if you like, parallel to the ground like a Scar arm, so would not be appropriate for the task reaching different heights. So that's that. But then obviously the very big change is I put some other objects into the 3D picture viewer to sort of simulate the shelves and a bit of floor, and then the turtle bot there in the middle. So between those two things, they're basically the main two things with the code. So I've still got the play all animation, if you will. That was a home position at the start and picking and placing into each shelf. I was going to not have this here and have it here, but then when I realized I had to have that joint anyway, I thought, sod it, I'll keep that over there because it looks a bit nicer. So you can see that running there. Obviously the kinematics I've shown you before. So if we stop, actually we'll keep that running. And the difference in the code is pretty simple. So we've got a few little comments and stuff added in, but this bit here is basically the stacked sequence is the new section. So basically the serial scene, the scene reference comes out and is fed into, and it adds in here the object, which is defined here. So for the first one, we're adding the cylinder, named it the turtle bot. We've set it to white, that's the color. Transform matrix, so this one's just raised up a little bit. That's the transform block added in and then sent out to the next part of that, which is in this one. So then it comes in, background to there, adds in the square for the floor, and then after the floor, we've got the wall, the low shelf, the mid shelf, the top shelf. And then the final one outputs a 3D picture. So that's all I've added there. Other than that, the code is the same. In my previous video, I also talked about this global variable here, the joint positions, and how that is used to communicate with SolidWorks. I have done that slightly, which I'm going to demonstrate now. It's not finalized and could still be improved, but I've done enough that I want to focus on other projects now. So I close this again and bring this over to one side, bring up my SolidWorks as well. Once I go into the LabVIEW project window, I can start simulation. And if I then go back to this, hold on, one more file to run, which is this one. There we are. Now minimize that one, here we go. So you should now see my SolidWorks model moving. So clearly the SolidWorks model does not line up to this, and that's for various reasons. One reason being that the actual model of the robot used doesn't match because I'm still using a 6R, how I have my previous robot configuration. On top of that, yeah, so from the previous robot, obviously I've got that end effector with the rotate, which I no longer have. The main reason this is so sort of skewed, if you will, in a really sort of incorrect configuration is just because of how I started it. Because this animation didn't start from the same place that this one did. So as this one's moving, this is moving the same amount, but it's not about it. For example, if I now go to the floor, they both will rotate round. There you are. So it rotated around about a third of the total revolution, roughly the same as this one. But the rest of the joints obviously are sort of in the wrong place. So in order to achieve that connection, I'm going to stop that now and just show you sort of how I did it, which is just with one simple extra VI, which is this one. So in a timed loop synchronized to my scan engine, I'm taking that same global variable, the joint positions, taking the first 4 joints, so it's only using my optimized joints, amount of joints, yeah, turning them into degrees, and then we're looking each time around this loop if the current value in is the same as the previous value from the shift register. If it is the same, then we're passing a 0, and if it's not, then we pass the difference between the new value and the previous value into move straight lines of that axis, which uses the soft motion add-in for LabVIEW and SolidWorks, which is also defined up here in my project window on the left. And you can see I've got my axes. I still have 5 and 6 just from my previous robot left over, and the actual SolidWorks assembly is there. I'm going to have a detailed video on how to sort of set up a basic interaction between these two, because there's not very good quality tutorials currently on YouTube. But anyway, that's different. So the reason for having to check if they're currently equal is because otherwise I would pass one set value of a joint position into each joint, and each time through the scan engine it would move that joint by that difference again. So obviously if I set it to say move around 45 degrees, or sorry, to set the joint to 45 degrees, it would continuously move it an additional 45 degrees each time through this timed loop, which is obviously not ideal. So that's to do with the difference bit. And as I scroll down, obviously I've just got my 4 axes, and then false to stop, because this one doesn't need to stop until I tell it to, which I will now, because I don't need it. But that is my updates. So we'll go back to this one, and we'll just do a little play all, so you can just watch that as the video ends. Thank you very much.